Let's look at this example. If you deposit 4,500 at 5% annually interest compounded quarterly, how much money will be in the account after 10 years? So the way I start this problem is first I have to label what I know, right? The starting amount is 4,500. That's my p-value. The 5% is the rate. Well, the rate has to be in a decimal form, so 5 divided by 100, which gives you 0.05. Compounded quarterly means 4 times a year, so n equals 4. The amount after 10 years, your t is 10. What we're looking for is the final amount after 10 years. Well, using the compound interest formula, we're solving for A. Plug in everything that you know, and then use the order of operation. So simplify what's inside the parentheses first, and then exponent would be next. We cannot multiply those numbers. That's not right. So you do the exponent first. This number, 1.64 and so on, do not round this number into 1.6 or 1.64. That will give you your answer is going to be a little bit off. So try to keep as many numbers as possible. That number times this will give you 7,396.29 cents. So that means after 10 years, you will have 7,396.29 cents in the account. Example number 2. How long will it take for 3,000 invested at 5% compounded semi-annually to grow to 6,000? Well, to double this amount at 5% compounded semi-annually, how long will it take? Well, again, this is my starting amount. That's your P. Interest rate, R equals 0.05. Semi-annually means N is equal to 2. And 6,000 is the final amount. That's your A value, right? So if I use the compounded interest formula, this is my A, that's your P, that's 1 plus the rate divided by N. N is 2 semi-annually, and then to the N times T. Simplify it. So what's inside the parentheses simplifies into 1.025 raised to the 2t, all that times the 3,000, right? To solve for t, I would have to get rid of this 3,000 first, divide both sides by 3,000. You get 2 equals this right here. Now, this is the exponential equation. So to bring down your exponent, apply the power property. That is, take the natural log or the common logarithm on both sides. So we'll go ahead and solve this problem by taking the natural log. Exponent comes up front, right? From this property right here, this is equal to this. So that means that should be equal to that. And since everything here has been multiplied, divide by 2 times the natural log of 1.025 on both sides to get t equals that, which is approximately about 14.04 years. So to double the amount we started with at 5% compounded semi-annually, it would take about 14 years. Example 3. The number of bacteria present in a culture after t minutes is given as b equals 10 e to the r times t. If there are 3,527 bacteria present after 3 minutes, find r, or the rate. Okay, so the number of bacteria increased to 3,527 after 3 minutes from the initial amount of 10. 10 is the initial amount. So what we're going to do is we're going to use the number 3,527. That's the final amount after 3 minutes. to find our rate. Let's use the compound or that formula that we're given. B is the final amount after 3 minutes, right? T is 3. And the only unknown variable here is the R, right? In order to solve for that, we're going to isolate the exponential portion first. So that is get rid of the 10 by dividing both sides by 10. You get 352.7 equals e to the 3r. That's an exponential equation. Take the natural log on both sides. Exponent comes out front. The natural log of e is equal to 1. So we have 3r equals the natural log of 352.7. To isolate the variable r, divide by 3. So the exact amount of the r would be equal to that. If I round it, I get a 1.955. Exact solution, an approximation solution. So in this case, the r would be equal to 1.955. Example 3. What principal P invested at 11% compounded continuously for 6 years will yield 1,210? Round answer to 2 decimal places. Okay. What principal P? We don't know the starting amount. We know the rate is 11%, and it says compounded continuously. So we have to use the compounded continuously formula. T is equal to 6. And of course, the final amount that we want or we will get after 6 years is 1,210. So that's what we know. We don't know what the p-value. So use the compound continuously formula, plug in everything. The known variable here in this case is the p. So we have to solve for p. In order to do that, we're going to get rid of this portion right here by dividing both sides by e to the 0.11 times 6. And of course, that simplifies into p is equal to $625.39. So we would need to start with about 625.39 cents to get this amount after 6 years. Example 5, which is polonium-210 has a half-life of 140 days. Suppose a sample of this substance has a mass of 300 milligrams. Find the mass remaining after T years. So in order to find the mass remaining after 1 year, I need to know the constant K, right? What is the half-life? Well, the half-life is for this amount that you started with. For that to decrease into half of it, which is 150, it would take about 140 days, right? So using the continuously compound formula, AT equals A0 e to the KT. AT is the final amount after T years. A0 is the starting amount, what you're starting with. K is the rate, and T is the time, right? So what we're starting with is the 300 milligrams, right? That's 300. T in this case would be the half-life, which would be 140 days. And because I'm interested in finding the K, I know it's going to take 140 days for this 300 milligram to decrease into 150 milligram, half of it. And if I do the calculation here, divide by 300, you get a 0.5 equals e to the 140 times K. Take the natural log on both sides. Exponent comes out front. Natural log of e is 1, right? So we have 140K equals the natural log of 0.5. Divide both sides by 140 to isolate the variable K. That's the exact solution right here for K, which is approximately equal to negative 0.004951. So For K value, try to use as many numbers as possible. Don't use negative 0.004 or 0.5. Now, to find the remaining amount after 1 year, I will use this as my K value. That's the initial amount. The K we know, the T we don't know, right? But we know the final amount that we want. Well, the final is what we want to figure out after 1 year or 365 days. So you have A of 365 is going to be equal to 300 E to the K, the value we came up with, and times T. Well, that's after 1 year. So remember, T is in days. So that means in 1 year, you have 365 days. And then if you simplify this, you get the final amount after 1 year will be 49.24 milligrams. That means it's gonna decrease from that 300 milligram that you have into 49.24 milligram. Example 6, assuming a half-life of 5,728 years, how long would it take for 3 grams of carbon-14 to decay into 1 gram? Okay, the half-life that it would take for 3 grams to decrease into half of it, which is 1.5, it's going to take about 5,728 years, right? That's what we know from the half-life. For this to decrease from 3 to 1.5, it would take this much. So let's use that to figure out what the K value is, right? So A0 is 3, A of T, well, that would be 1.5. The T is the half-life here, which is the 5,728. K, we don't know, the constant. So divide both sides by 3, you get a 0.5 equals e to the 5,728k. Take the natural log. Remember, exponent comes up front. Natural log of e is 1. So this would be 1. Divide both sides by 5,728 to get the k isolated. That's the exact amount of k, or you can round it to negative 0.000121. Remember this, you don't want to round. Now we're going to use this k value to figure out how long it will take for the 3 gram to decay into 1 gram. That is, we're starting with 3. For that 3 to go to 1 gram, how long will it take? What would be the t value? Right? Final amount, what we started with, our k value, and we don't know what t is. Divide by 3, right? Now, the next step would be to take the natural log. Remember, when you take the natural log on both sides, you will have the natural log of 1/3 is going to be equal to exponent comes up front, and then you would have times the natural log of e. This natural log of e is 1. Divide both sides by negative 0.0001 to 1 to get what t is equal to. And that t is going to be approximately about 9,079 years. So it would take 9,079 years for that 3 grams of carbon-14 to decay into 1 grams of it.